Hello there and welcome to the June 2019 paper. Here we're looking at question 6. An art display consists of an arrangement of n marbles. When arranged in ascending order of mass, the mass of the first marble is 10 grams. The mass of each subsequent marble is 3 grams more than the mass of the previous one, so the rth marble has a mass of 7 plus 3 r grams. Show that the mean mass in grams of the marbles in the display is given by this expression here. Now remember, the mean is add all the marbles up together and divide by n. So let's add all of these marbles up together. Let's just add all the marbles up together first rather than dividing by n yet. So we'll just divide, we'll just add up from 1 to n the marbles of 7 plus 3r. So let's split up this series. It's going to be the series from 1 up to n of 7 plus 3 lots of the series from 1 up to n of r. So let's simplify this. It's going to be 7n plus 3n over 2, n plus 1, which is going to equal 14n over 2 plus 3n over 2 n plus 1. Let's now factorise out the n over 2. That's going to give us 14 plus 3 lots of n plus 3. So this will equal n over 2 brackets 3n plus 17. So therefore, the mean is going to equal this summation of 7 plus 3r over n, which is equal to n over 2 brackets 3n plus 17 divided by n, the amount of marbles there were. So then we divide by the n's and we get half 3n plus 17. Okay, so there we are. That's the answer for the mean there, having shown that in part A. That's 3 marks. Let's now move on to part B. Let's move on to part B. So given that there are 85 marbles in the display, or effectively n equals 85, use the standard deviation formula to find the standard deviation of the mass of the marbles in the display, giving your answer in grams to 1 decimal place. Now the formula for the standard deviation equals the square root of the sum of x squared over n minus the mean squared. Okay, so let's now first do this top left hand feature here, which is the sum of the marbles squared. So this is going to be the sum. So it's not to press equals, let's just say, right, now we're going to do the sum of x squared. So this is going to be the sum from r equals 1 up to n of the marble formulae was 7 plus 3r squared. So we're doing the sum of x squared at the moment. So this is going to be equal to the sum of r equals 1 up to n of 49 plus 21, 42, 42 sum of r plus 9 sum of r squared. So let's work this all out. Sum of 49, n lots of 49 is just 49, plus 42 over 2, n plus 1, plus 9n over 6, n plus 1, 2n plus 1. Now we need to simplify this expression here. I think if we make it a factor of 2 on the bottom, so it's going to be 98 over 2 plus 42 over 2 n plus 1. Oh, it's supposed to be 49n, plus 3n over 2, n plus 1, 2n plus 1. Let's factorise it now, so it's going to be n over 2 brackets 98 plus 42 n plus 42, expanding the brackets on the n plus 1. Then it's going to be 3 times n times 2n, so that would be 6n squared. This would be 3, so that would be plus 9n and then it's going to be plus 3. Close the brackets. Let's now simplify all of this. It's going to be n over 2 brackets 6n squared plus 42 plus 9, that's going to be 51. And then 98, let's do this on the calculator. 98 plus 42 plus 3 gives us 143. Okay, so there we are. That is the summation for x squared. Now the summation for x squared over n, summation for x squared over n is going to equal this thing here divided by n. So it's going to be a half bracket 6n squared plus 51n plus 143. Right, so the next thing we need to now do is this minus the mean squared. So now mean squared is going to equal, the mean was on the previous page here, it was this expression here, so a half 3n plus 17 all squared. So it's going to be half 3n plus 17 all squared. So it's going to be a quarter, because the half gets squared, and then 9n squared plus 3 times 17 times 2 is 102, and then it's going to be plus 17 squared, 289. So now that we've got these two expressions here, sum of x squared over n and the mean squared, we can now subtract one from the other. So therefore, the sum of x squared over n minus the mean squared is going to equal, let's factorise out a 4, so it's going to be a quarter. Now I can double all of these numbers inside here, so it's going to be 12n squared minus 9n squared, that would be 3n squared. Then it would be 102 minus 102, that will cancel out. And then 2 lots of 143, 2 times 143, that's 186, minus 289 will give us minus 3. So therefore, the standard deviation is going to equal the square root of a quarter, 3n squared minus 3. And now all that's left for us to do is to find the standard deviation to one decimal place, to substitute in n equals 85. So let's grab a calculator and do that on the calculator. So it's going to be fraction button 1/4 times the square root of, the quarter goes inside the square root, so it's 3 times 85 squared minus 3. That's going to be 73.6 to one decimal place. So we've substituted in n equals 85 and got 73.6. And there we are, that's the answer for question 6 there, 9 marks in total for that one. Very difficult question, this one, because if you didn't get the standard deviation bit right at the start and then know how to apply it in this question, very difficult question indeed. So there we are, that's the answer to question 6. Let's now move on to question 7.